Hello, today we're going to talk about comparing the properties of two different represented functions. So a function is a rule that assigns to each input exactly one output. So what we're using for this is called slope-intercept form. Y equals mx plus b. Alright, when you're talking about slope-intercept form, you have a slope which determines how fast something changes. Or it can also be called the rate of change. The y-intercept over here is your original number or starting point. All right, so if you have two different functions, all right, when you look at the slope, you can compare how fast something's growing or how slow it is, and then you can look at the original starting point. So for an example, if you're looking for a plumber, all right, you're looking at plumber A and plumber B. Plumber A, all right, it's going to charge you $90 to come out. Just to show up at your house, it's going to charge you $90, and after that, it's going to be $20 per hour after. Plumber B is only going to charge you $50 to come out and check on things, but he charges a little bit more. He charges $25 per hour. All right, and this will happen to you over time. You'll want to compare two different things. All right. So what you're basically doing in all that is you're setting up two functions or two linear equations to figure out. So whenever you say $90 to come out, that's your y-intercept. That's where you start. So no matter what here, you're getting charged $90. No matter what here, you're getting charged $50. If he gets in the car, drives to your house, if you're not there, you're still getting charged $50 or $90. Just happens. All right, if he goes out there and spends 1 minute, $90, $50, all right? This right here is your slope. So my slope says how fast this whole thing's going to change. So this is going to change 20 for every 1 hour. It's going to increase the price. This down here is going to change 25 for each hour he's there. All right? And this is how you compare the properties of them. So this guy is going to be cheaper if it's a quick fix. Or no, he's going to be more expensive if it's a quick fix. Because if it's a quick fix, he's going to charge you $90. He's done in 30 minutes, or he's done an hour, $110. Right down here, if he's the one you want if it's a quick fix. So $50 to come out, 1 hour, $75. Right? But if it's a 4-hour project, you're going to spend $50 and then another $100, so $150. Here, 80 and 90, 170, he's still cheaper. We'll go up. It was just an example I thought of in my head. 10 hours, so 250, 300. This is 290. All right? It's just depends on the hours. If I even increased this and said $30 an hour, that'd probably be better. All right? It just depends how you're looking at it. He might have the smaller charge fee at the beginning, but overall, you're going to end up spending more. If it's a long project, if it's a short project, that's good. You spend $80 and that's not even what they spent originally. All right, so that's how you compare it. Here, the money, because it's per hour, is what changes it. The y-intercept is what the original number, what you have to pay no matter what. All right, when you're talking about slope, which is the m, right? You have two different slopes here. You have a positive and a negative. So if you're talking about something like money when it comes to comparing two functions. So let's say over here I have my function is negative 2x plus 10, right? So what this is saying is I'm losing $2 for every whatever, or I'm losing 2 for every whatever, but I started with 10. Let's switch it to 20 just for the fun of it. So this is usually spending money in an arcade is what you usually see. So I'm at an arcade, my original amount, so I walk in with $20 to an arcade. For every game, so X is the games played. Alright, so for every game he plays, he's gonna lose $2. Or every hour he's there, he loses $2. Right? So this is losing something, whether it's money, fuel, something like that. If it's positive, you're gonna have something like this, and that's gaining. So I start with $20 this week and I make $2 for every book I sell for some strange reason. So it's increasing the amount of money I have. So spending, losing, using gas, that's all negative slope. Positive slope would be gain. All right, now we're gonna find the slope of all these and tell which one's the fastest, which slope is best, or which rate of change, from least to greatest, or I'll do from greatest to least, it doesn't matter. All right. So say here you're comparing jobs. This is job A, job B, and job C. Which one are you gonna get paid the most at for the amount of hours you work? All right, something like that, and you're just comparing the three. You might not realize it, but you're gonna do this throughout your life. You're just not gonna know it's a linear equation. All right, so I find my slope here. I can do rise over run if I want. I'll make my triangle, why not? So I'm going up 15, and I'm going over 3, so y over x, so 15 over 3, which is 5. Alright, here I'll do the table way. I'll do it all 3 ways. Why not? I'll go down on the table. So to get from 6 to 7, I have to add 1. To get from 12 to 16, I have to add 4. Y over x, which is 4 over 1, which is 4. So now, this job looks better than this job because I'll be making, say, $5. Here I'll be making $4. And this is just a general idea. This isn't the actual thing. And I'm just making this up sort of as I go. So you get 6 over 1, which is 6. Alright, so the best job would be C, the next job would be A, and then B. C is my greatest rate of change. How I did that was, well, I'll do it the other way because I said I would. So y2 minus y1 over x2 minus x1. So 32 minus 26 over 12 minus 11 gives me 6 over 1. And there you go. So the best job to take would be this one right here. All right, now for the last one, we just compared slopes, but here we go. We got 2 different jobs again. Why not? And we want to know what the best starter is. So when I talk about starter, or how much it's going to cost me at the beginning, I'm talking about my y-intercept. All right? So I know my y-intercept here is -5. That is not a good starting point. All right, it's very, very small. So again, these scenarios aren't very accurate because I'd be paying $5 to get my job. Here to find the y-intercept, find the rate of change or the slope. So here I have to add 2 to get there, and I have to add 1 to get there. So y over x, which gives you 2 over 1, which is 2. Now I've used some common sense here. do 1, 2, not 0. Hold on. 0, 1, 2, 3, and 4. Now, I know every time I go up one here, I go up one here. So if I went to 4, I'd go to 8. 3 to 6, 2 to 4, 1 to 2, 0 to 0. Yeah, because I went down 2 every time. There we go. So over here, my y-intercept is 0. So what's greater, 0 or -5? 0. So this has the greater y-intercept. All right, this has been comparing the properties of two differently represented functions.